This tutorial is going to run through setting up NES with a tiled map. We're going to create just a really basic platformer kind of map so we can see the process of getting up and running with NES and getting a tiled map imported and all that fun stuff. So it's going to be assumed that you have MonoGame working. So we're gonna jump right in, starting with that assumption. And if you do have MonoGame installed correctly, you'll have project templates here. So we're going to go with the cross-platform desktop project. That's what you're going to want to use in most cases, unless you're targeting specific mobile platforms. So we'll just call this platformer and create that on the desktop and jump right in. Okay, this is going to create our project, and old bug with Xamarin. It creates the project sometimes but doesn't actually open it, so we just have to manually open it. Alright, so we have a project. Let's run it. Ooh, got a problem. It's running, but it's not running. And you can see up here it says Mono 32. That is just the 32-bit Mono runtime, which is more or less deprecated at this point. It's pretty much a goner. So let's go into the compiler here and change this so that we're building 64-bit. So now if we run it, you can see we have the Cornflower Blue screen up and running. So we're good to go. We have a functioning MonoGame project ready to go. Let's go ahead and download NES so we can get that in here. So normally you'll probably just want to clone this so that you can grab updates, but for this particular case we're just going to download a zip file. Keep things nice and simple. Okay, so we have NES here. We'll just unzip it. And what you're going to want to do first is just open up the NES solution and just build it. And this is going to create the DLLs that we need. So now we can go back to our platformer and we can get it ready. So first thing we're going to do is add the NES project. And that's in the NES PCL folder because it's actually a PCL, Portable Class Library. So let's add that first. Okay, good. Next thing we're going to want to do is add the NES pipeline project. And pipeline projects, for those of you that don't know, are just projects that you can use with the MonoGame pipeline tool that allows you to build custom file formats. And we're going to need that because NES has a custom tiled importer. So let's go ahead and add this to our project. And I mean, technically we don't need to add it because we just need the DLL, but just in case we'll keep it in there. So now we're going to open up our platformer and add a reference to NES. Now important here, we do not need to add a reference to the pipeline importer. Pipeline importer is not used in your actual compiled game. It is only used by the MonoGame content pipeline, which we're going to open now by just double-clicking the content.mgcb file. Okay, so let's just do a little bit of setup here. First things first, platform is not Windows. We're actually desktop GL. And our profile is not Reach, it's high def. So we got that set, and now we need to let the pipeline tool here know about the NES pipeline importer. So what we're going to do is click collection, and what collection is just it's like basically adding a reference. So we're going to go into our built project now, because remember we did a quick build. So there'll be a bin folder, and we can fetch the DLLs that we need. We need the NES pipeline importer DLL, we need Newtonsoft JSON, and Ionic zlib. So select those, click add, and click OK. So in order for any DLL changes to work with the pipeline tool, you have to close it and reopen it. So let's just close it for the moment. We won't reopen it just yet. Now, if we're going to do anything with a tiled map, we're going to actually need a tiled map. So I took the liberty of creating this beautifully complex map here, and an incredible tile set you can see here. It consists of a whopping 3 tiles. There's a block here, and you can't really see it, but there's just a thin platform here, and then the coveted sloped platform there. And you can see the tile set here. So you can just draw in here like you normally would with any tiled map. Okay, so we have the tiled map already in there, so let's just put it in our project folder here so that we can actually get to using it when the time comes. So here it is. I'm just going to take it and stick it in here. And now when we open up our content tool, it's going to have those DLLs loaded, so we'll have all of the NES pipeline importers. So we can add existing item, and here it is, our untitled TMX, the tiled map, and the tile set image. So we're going to add those, and they should get set up automatically for you just based on the file extension, but let's just check. So if we look at the TMX file, we'll see that it's using a tiled map importer and a tiled map processor. That's great. And we can right click it and build, and you can see that we have one layer here and it's succeeded in its build. So let's just build this as well, and our tile set built as well. Okay, great. So we're done with that. We don't need the content pipeline app anymore. Any changes we make to those files will be picked up automatically, so we don't need to worry about that in the least bit. So now let's jump in and actually get our project here ready for NES. So first thing is most of this game class is going to be gone, so let's just gut it now. We don't need any of this stuff. We will need the initialize method, but we'll get to that in a minute. We don't need any of this, and we can get rid of all these unused usings here, and we're set. So now what we're going to need to do is our game class is going to need to subclass nes.core. So let's do that, and you can see you've got a red underline because we're missing a using. We can let that automatically get added, and now we're ready to roll. So if you want to customize NES at all, you can do that when you call the base constructor. So by default, those are your settings, and you can change those to whatever you want. The thing that we're going to want to change here is the window size. Our tiled map is 640 by 480, so let's make it 640 by 480, and that's really all we need there. So we can go ahead now and actually start coding. So NES works with entity component system, and it also uses scenes to organize things. So the first thing we are going to want to do is make a scene. So we create our scene file and we subclass scene. And we get the little red line, so let's get our using in there. And we have a scene. So for scenes, basically when you create your scene, there's different methods you can override, and if you use the good old context-sensitive autocomplete, you can see what we have in here. So for us, we're going to just be interested in the initialize method. And what we're going to want to do here is just add a renderer. So a renderer is what's actually used to render any sprites. You have to have at least one. Actually, let's just go ahead and not add one yet and see what happens. So over here, let's load up our scene. Okay, so we run it and it poops itself. So we're going to hit one of these asserts here, and if we look in the stack trace, we just see scene has begun with no render. At least one renderer must be present. Okay, good. When you're using NES, there should be useful asserts when you do things incorrectly like that. Hopefully there's enough of them to make sense of things. So let's add a render, and we're just going to add a default render. Default render is the I don't care about anything render. It will just render all layers, all render layers. It renders everything. So it's nice and easy for getting up and running quick. And while we're at it, let's set our clear color. And we get the good old red line here because we're missing the reference. Let's get that reference in there. Okay, so now we have a renderer, and now we have a clear color. So if we run this now, okay, great. Now we have our window set up. We have NES running. So there's one more thing we're going to want to do in with NES before we do anything, and that is set up the way that our render is actually going to work. So this is set up by just hitting the scene and set default design resolution. So I won't get into this too much. There's another YouTube video that actually goes over every one of the scene resolution policies. But just in quick fashion, what this is doing is it's telling NES what size the back buffer should be and how to actually display the back buffer. So for our particular case, we have a 640 by 480 back buffer that we're going to ask for, and we want show all pixel perfect. So that means that no matter what size the window is actually displayed, NES should always display it pixel perfect. And just to have a quick look at that, we can say is mouse visible is true, and window.allow user resizing is true. So now we can resize the window and just see what's going on here. So if we resize the window, actually we can't really see it too well here because we don't have any art, but you can see this would be pixel perfect at 640 by 480, and it will, until we get to a resolution, see here it jumped up to a bigger resolution because it can fit, but if we go just smaller than what can fit, it'll jump down in pixel perfect increments. And again, the scene resolution policy video will have examples of all of those so that you can see. They're super handy. Our window's a little bit small, so I'm just going to go ahead and double this here. And what this is going to do is it's going to make the window double the size, but our back buffer is still only going to be 640 by 480. So we're not going to be rendering any extra pixels here. All it's going to be doing is, in the final render, it'll upscale it perfectly for us to fit. And there we go. Okay, so we have our scene set up, we have our default design time resolution and our resolution policy set up. So we are ready to jump in and actually start making a game. So what we're going to need to do here is, in order to display a tiled map, we're going to have to actually load that tiled map. So this gets into the Monogame content system, which NES just extends and adds some new features for you. But the first thing we need is we had that tiled map, so we're going to want to load that sucker up. So let's do that. So with NES, you have access to content in every scene. And what content is it's a subclass of the content manager. This is where you manage all of your assets. So what that lets you do is, in a scene, you can load whatever you'd like, textures, tiled maps, sounds, and when that scene is changed to a new scene, NES will unload all of it for you. So for our particular case here, we want to load a tiled map. And what we're going to see here is we have the little red line, so let's just go ahead and add the reference. It'll add the reference for us. And our tiled map was called Untitled. If you forgot, we can just look in here and see the tiled map is untitled. Now we won't need to load the tile set because the tiled map will take care of that for us. So we only need to know that. So given that we have our tiled map all loaded now, we need a way to display it. So this is where we're going to get into the entity component system. There's a component called a tiled map component, and it knows how to display a tiled map and has various different settings in there that you can play around with. But for now, what we're going to want to do is just get this tiled map displayed so that we can see it. So first thing we want to do is let's create an entity to house that component. Entity is at the top of the list here, and components are added to entities. So we have our tiled entity, and now we can go to our tiled entity and add a component. And the component is the tiled map component. And it's going to want a tiled map and a collision layer name. So we have the tiled map. Let's just jump with that to start with. And if you ever want to see what's available to you with NES, everything is organized into nice neat little folders here. You can see in the entity component system there's a components folder, and you can run through these to look and see what components are already built into NES. And the game is going to consist of mostly custom components, but you'll also probably be using the built-in components quite a bit, like sprites and tiled maps and whatnot. So let's go ahead and run it. And oh, what do we got? We have a content load exception. Could not load untitled asset as a non-content file. The astute among you will have noticed that I spelled untitled very well. So let's go ahead and run that. All right, so now we're good. So we have our tiled map running. We have our resolution policy working, so let's just see how that looks with actual content. So now you can see it's always going to be pixel perfect. Excellent. So step one's done. We have a tiled map and we're displaying it. So next up, we're actually going to want to get some collision data in that tiled map. So let's go ahead and open the tiled map up in tiled. Okay, so here's our tiled map, and you can see we have one layer, and the layer is called main. So main, for this particular tiled map, we don't have any parallax layers or anything odd going on, any background layers. So for this particular case, we're just going to use main as our collision layer. So we can go right in here and just add that. So we do another build, and it doesn't look like anything has changed, but let's have a look in a different light here. So if we use the tilde key, it brings up a Quake-like console here, and you can see you can type in different things. These are the built-in ones. If you type in help, you'll see everything that's available. Let's first just set the console scale a little higher. Actually, well, yeah, I'll first set it higher and then we'll see. Okay, so if you were to type help and then a command, for example, the one I just used was console scale, you get a little bit more data about it, and it sets the scale the console's rendered. And you can see the default is 1. So for what we want to look at here, we're going to just have a look at a debug render. So if we turn debug render on, I'm going to hide the console, you can see that we have all of these colliders automatically added for us. And just to see them in another light, let's look at doing physics. So what this is showing you the spatial hash of the physics system, and I'm going to make that last a little bit longer this time, so the time that it actually displays is available to you here. So you can see that this particular node has 2 colliders in it. This one only has 1, and spatial hash is something that's happening behind the scenes and just makes collision queries super fast. Okay, so we see our actual collision layers working properly now. So we're all done with the actual tiled map. So next thing we need is we need a player to be able to jump around there. So let's create a new entity. Okay, so we have our player entity now created. So we need a way to see our player. NES has something called a prototype sprite. So what we're going to do is just add one of these. All a prototype sprite is it's just basically a squared sprite that you can add for prototyping really quickly. So I'm going to go ahead and add the prototype sprite in. And you can see it takes in a width and a height. We'll do, our tiles are 16 pixels, so we'll do 1 tile wide and 2 tiles high. And if you wanted to see some of the other things you can do with prototype sprite, the properties are all up here. So it lets you add skews, for example, if you wanted to skew it when you're running, just to give it a little bit of life. You can do that. You can also set the color, which we should probably do, so that it's not white. Okay, so now let's run it and see what we got. Okay, we got nothing. And the reason for that is that we are displaying our prototype sprite behind our tile map, and it is at 0, 0 up in the top left corner. So that's all good and well. We're going to need this to get our player positioned somewhere in a more useful fashion. So we're not going to mess with that here. What we're actually going to do is jump back over to our tiled editor and let's set up a proper spawn point. So in tiled, I'm not going to get too detailed into tiled here. Tiled has tutorials all over the web, but what we're going to do is we're going to take advantage of their object layers. And I'm just going to create a new object layer, call it objects, and I'm going to create a spawn point, which will just be a square. Just zoom in here and Stick a spawn point here. Okay, so we have our new object, and it has no name by default, so let's call it spawn. And now we have somewhere for our player to live. So we have the spawn ready. Let's go back over here and let's actually get that spawn. So what we want to do first is get access to our object layer. And the way we do that is by asking tiled for the object group. We called it objects. So we'll grab that, and then we can grab the spawn from the object layer via object with name. Okay, so now we have our object here, and it's of type tiled object. So if we jump in here, just jumping to definition, we can see that the tiled object has a bunch of different properties that'll all be available for us. Mainly for this particular case, we just need X and Y. So let's move the player. So the transform of any entity is what controls its position, rotation, and scale. So we'll set the position to spawn.x and spawn.y. Now we run it again, and there's our player, right where it should be. Beautiful. Okay, so our player obviously isn't moving or doing anything useful at this particular point in time. So we're going to need to create a new class to actually handle controlling the player. So let's go ahead and do that. We'll make a player controller. And player controller is going to be a component. Let's go ahead and add that component. You can see we added the component in a slightly different fashion this time. So you can either new the object, or you can just pass in the type of the object, as long as it has a constructor with 0 parameters. So we have a constructor with 0 parameters, so we can go ahead and just set it up like this. So our player controller is going to need a couple things too. First thing it's going to need is a way to move around the tiled map. We don't have to build that ourselves. It's already built into NES. And the class is called tiled map mover. There's also a regular mover class that you could use for non-tiled map situations. You can see it needs to know the tiled tile layer of the collision layer. So we can get at that pretty easily by just using our tiled map and saying get layer. And get layer has a few different variants. You can see it has 4 different variants. You can get the layer by name or index, and you can get it strongly typed or weakly typed. So for us, we want a strongly typed one because we need a tiled tile layer here. And we know that our layer is called main because we use it up above. Okay, so now our player has a tiled tile map mover. And we're missing a parentheses. So next up is we need to add a collider. So the tiled map mover requires a collider. And if we just hop in here, it has quite a few different configuration options. We're going to keep everything default now. You can dive on this in your own time. But for now, we'll just keep everything as is. So let's add a collider for our player to work with. And it's going to use a box collider. So we're always dealing with boxes when we're dealing with the tiled map mover. And our player was 16 by 32. So let's go ahead and create a 16 by 32 box collider. So if we go ahead and play it now, we're not going to be able to see anything. But if we remember, we can just type debug render. And you can use tab for autocomplete here as well when you're in this console. And you can see that when we do our debug render, the box collider is actually centered on the position here. So we're going to need to shift that up. And we can do that with the other constructor of the box collider. Looking in here, there's a constructor that takes an X and a Y along with the width and a height. And it automatically sets the local offset of the collider for us. The local offset is just in local space, where is the collider going to be positioned. So for our particular case, we just need it to be positioned over by half the width and half the height. So if we look at this again, we can see now our box collider is perfectly lined up. Okay, awesome. So we're pretty much done with our scene. We can start actually creating our player controller now. So player controller is going to need a few things. Let's just add those right away. We're going to need some type of move speed so that we know how fast to go. We're going to need a gravity value because we're making a platformer kind of game here. We're going to need a jump height, so it's a platformer without jumping. And what we'll do for our jump height is we'll just say 16, our tiles are 16 pixels high, so we'll say we can jump 7 tiles high. Okay, so now we need to get access to a couple of these components here in the collider. So how do we go about doing that? In our player controller, let's go ahead and just type override so we can see what's overrideable. So we have lots of different things we can override in here, and what looks interesting here is unadded to entity. We don't need to call base on these. They're all empty base. They're empty base methods, so you can just override them, not worry about calling base. So unadded to entity is called when we are added to the entity. So when we're added to the entity, we know that we can then access the entity and fetch what we need. So the things that we need are the tiled map mover, and let's just add the reference. We've got our mover. We're going to need the box collider, and that's all we're going to need. So let's fetch those. So the way we do that when we're fetching the tiled map mover, it's a component, so we just say get component, and you specify the type. For our box collider, similarly, we're going to just ask the entity for the collider, and you again do it by type. Okay, so now we have our box collider, we have our mover component, so we can actually start using them. So the way the mover works is you pass it a velocity, like a delta position. So velocity times your delta time, and mover will handle all collisions for you. So we need a way to get a tick method or an update method called on this class here. And the way we do that is we just specify here that we want iUpdatable. So we can implement this, and you can see we get an update method. Perfect. So by default, the component won't have anything called each frame. When we add iUpdatable, we're telling Nez, hey, we want to make sure that an update method's called for this particular component every tick. So in this update method, what we're going to want to do is just eventually we want to get to calling mover.move so that we can move the player. But we need to get some state first. We need to know what the input is and set ourselves up with a velocity first. So let's go ahead and give ourselves a velocity vector to work with. And we'll add this. Okay. So what we'll do is we'll check input and fill in this velocity. With Nez, all input will come from the input class. It's a static class, and you have various methods here. For our particular case, we're just going to work with keyboard input. And we have 3 different states of the keyboard. We have pressed, which is the frame that the button is actually pressed. Release is the frame that the button is released. And down will be true whenever the button is down. So for this particular case, moving left and right, we'll want to go ahead and use down. And we get at the different keys that are available via the keys enum. And you can see that we get the little red line, so let's add our using. Okay, so if we're going left, we'll just set the velocity to minus our move speed. Same if we're going right. Except our velocity will be a positive value. And if we're not moving at all, velocity is going to be 0. Okay, let's see what we got. So we run this and we're not getting much of anything. Why is that? Well, we're not doing anything with the velocity. So if you remember, what we need to do is we need to actually call mover.move. Mover.move takes in a few things. It takes in the motion, the delta motion. So for us, we have a velocity, and velocity times time equals distance. So we're just going to, actually, that's delta time. We're going to use delta time here so that we could be frame rate independent. So that'll cover the motion. So we need a box collider. We got one of those. And here's something that we don't have, a tiled map mover.collision state. So we're going to need to create one of those. And the collision state, as its name suggests, just handles keeping all the state of the move that it does here. So when we call move, what's going to happen is the collision state is going to get filled in for us. So why do we have to pass in a collision state in a box collider? That's was an interesting design decision of the tiled map mover. And the reason that we do that is so that the tiled map mover, a single tiled map mover, can be used for all the entities in your scene. So it contains no internal state itself. That's why we have to pass in the box collider and the collision state. That way we can have 10, 12, 20 different AI all using that mover, just passing in the state. So now we can go ahead and run it again to see what we got. Okay, so now we can move, and we even have proper collisions here, but we're not really moving like a platformer. We don't have gravity. So let's go ahead and apply gravity here. And we'll just make a little note that this is our moving. Our mo. Okay, so let's apply gravity. Gravity is an acceleration. So because of that, when we apply gravity, we're going to need to multiply it by time.delta time. So again, you take an acceleration, multiply it by time, and you have a velocity. And that's what we have here. You take a velocity and multiply it by delta time, you get a position. So now we should have a nice falling, and he indeed does fall very rapidly. We can mess with that later. Okay, so we're applying gravity, we're moving. What we need to do now is deal with updating velocity after we move. So what's going to happen is that collision state is going to get filled in with stuff. What kind of stuff? Let's take a look. So you can see we got a whole pile of bools here. So if we collided left, right, above, or below, that's handy. So we know if we became grounded this frame, that's useful if you want to play a sound effect or poof particles or something. Was grounded last frame is useful for a few things, and is grounded on a one-way platform. That becomes important when you want to jump down through one. For our particular case, these are going to be the important ones. So let's update velocity here. So if we smashed our face into something, that'd be collision state right or collision state left. We can just set our velocity on the horizontal plane to 0. Same goes for if we smashed our head or our feet. And we do that so that we don't keep accruing velocity when we're grounded. That's why we ended up falling so crazy fast before, because when we were grounded here, we just kept accruing velocity even though we weren't moving. So now that we did that, we can see we get a nice fall there. So let's add one more thing to this class, and that's going to be jump. So we'll use the Z key for jump. We want to use is key pressed this time. We only want to apply the jump for the single frame that the button is pressed. Okay, so now we can do velocity.y, and when we're dealing with calculating a jump, there's tons of different ways to do this. The quick and dirty way that I'm using here is just to use the square root of 2 times the jump height times gravity. What that does is it creates a velocity that will be just enough to get us to our jump height based on the current gravity. And when we jump, we do need to make sure that we're going up. So add the negative. So let's see what we got. Okay, so now we can jump. But we can also triple, quadruple jump. Okay, so let's limit our jumping to when we're on the ground. So what we'll do is we use our handy collision state here and only jump when collision state dot below is true. Okay, so now pressing the button only jumps when it's supposed to. So here's something over here. Let's see what happens when we go off our slope. You can see that it doesn't actually work like a slope. And that's because we haven't set it up. One-way platforms, same thing. We can't actually jump through them. We're hitting our head on them. So we're going to need to actually set those up in tiled. NES needs a little bit of metadata to work with. And what we can do is let's just hop into the code comment here for the tiled map mover, and we can see what we have available. And these are the different properties that NES will parse out of the tiled map for us. So first of all, let's set our one-way platform up. So we have the NES is one-way platform Boolean. So these are properties on the tile themselves. So we choose our tile here, and you can see we have our custom properties pane here. We can go ahead and add a bool property and set it to true. All right, let's test it. So now we should be able to jump right through. And look at that, we can. So you'll notice we didn't have to do anything in the content pipeline. Monogame will actually rebuild the content pipeline for us when things change. Okay, slopes are going to be a little bit more work. So the first thing we need to do is tell NES that it's a slope. That's easy enough. So that's a Boolean, and okay, now it's a slope. So now NES knows it's a slope. 2 more bits of information are going to be required. You need to know the slope top left and the slope top right. So reading this little comment, you can see that slope top left is the distance in pixels from the tile's top to the slope. And the reason why NES needs to know this is it needs to know if the slope is a 45-degree angle, if it's a 22.5, 11, or whatever else you want to make. So let's add that. And that property is an integer. Top left is just going to be 0, because if we look at our little slope tile here, we can see that the top left is 0. Pixels from the top, that is. Top right, on the other hand, is going to be a little different. So let's pop that in here. And our top right is going to be 15. Because, again, this is the number of pixels from the top, which is here, down to the actual slope of the tile. So it's going to be 15. Okay, so now we have that set up. And you'll notice when we look over here, actually, we'll draw a couple more here. Let's go back to our main layer. And you can see that our slope here is actually in the opposite direction versus this particular one. And that's totally fine. NES will work fine when you flip the tiles around. It knows what to do, and it'll handle that appropriately. Okay, so we save that, jump back in here. So now NES has all the information it needs to mess with slopes, and you can see, sure enough, that we can play on these slopes, and we stick to them properly when we're running up and down them. And one neat thing NES does here is you can see that it will actually line up the slope to the center, as opposed to having the left or the right edge be all the way over here. So that way you can have your sprites have a little bit better look on the slope. It looks more like they're on it. All right, that's it. That is setting up a tiled map with NES and getting a player moving around. Obviously there's tons more to do for a real game, but considering we only wrote like, what, 60 or 70 lines of code, it's a good start. Thanks for watching.